The problem we will be discussing today is why resveratrol increases mitochondrial biogenesis in mice but not in humans.
So the mass that we're going to be looking at for this problem is mitochondrial content. We're not going to necessarily be looking at any outflow because there's nothing that would decrease mitochondrial content. But we are going to be looking at inflow as PGC1 alpha and looking at how it affects mitochondrial content. And it does that by activating the transcription and translation of mRNA, and that in turn does increase the mitochondrial content. There are many factors that activate PGC1 alpha. There is calcium that activates CAMK, activating P38, which in turn activates PGC1 alpha. There is SIRT1 that activates PGC1 alpha via deacetylation, and there's also AMPK, which activates PGC1 alpha. Today what we're going to be looking at is SIRT1 and AMPK. As we just said, AMPK and SIRT1 both work to activate PGC1 alpha. AMPK directly activates PGC1 alpha, as well as indirectly activating SIRT1 via NAMPT. Both of these substrates, again, work to activate PGC1 alpha. Therefore, if there was some sort of exogenous substance that increased SIRT1 as well as AMPK, there would be an increase in the inflow of activation of PGC1 alpha, therefore causing an overall increase in our mitochondrial content mass.
So, given the question that we are looking at, which is why resveratrol increases mitochondrial content in mice but not humans, our hypothesis is that resveratrol specifically activates SIRT1 and AMPK in mice but not in humans.
In a 2012 study by Dolinsky et al., which looked at the effects of resveratrol in skeletal muscle, it was found that there was a significant increase in the expression of PGC1 alpha in mice that had gone through exercise training with a supplementation of resveratrol compared to those mice that had gone through exercise training without the resveratrol. This is evidence to support the first part of our hypothesis, which states that resveratrol activates SIRT1 and AMPK in mice.
In a 2014 study by Scribbins et al., it was found that resveratrol has no acute effects in humans, but there are acute effects in mice. This was stated to be due to increased bioavailability of resveratrol in the skeletal muscle of mice that was not seen in humans.
So in conclusion, these studies support our hypothesis that resveratrol activates SIRT1 and AMPK in mice, but not in humans. And this is due to the fact that there is significantly more resveratrol present in the skeletal muscle of mice than there is in humans. So therefore, in mice, this presence of resveratrol is going to significantly increase the activation of AMPK and SIRT1, which will increase PGC1 alpha and the inflow for mitochondrial biogenesis, which ultimately increases mitochondrial content. And in humans, resveratrol is not responsible for an increase in mitochondrial content.